Mendel and the peas. Gregor Mendel, an Austrian monk, is considered the father of genetics. Mendel studied the inheritance of various traits in pea plants. One such trait is whether the pea is smooth or wrinkled. Mendel predicted a ratio of 3 smooth peas for every 1 wrinkled pea. In one experiment, he observed 420 smooth and 133 wrinkled peas. The data were produced in such a way that the random and independent conditions are met. Carry out a chi-square goodness of fit test based on Mendel's prediction. What do you conclude? Okay, so the ratio is 3 to 1. So the proportion of smooth peas was 3 out of 4, and the proportion of wrinkled peas was 1/4, right? So we want to perform a test at the alpha equals 0.05 significance level of, so H naught is going to be what Mendel predicts, right? The proportion of smooth peas will be about 75%, and the proportion of wrinkled peas will be about 25%. Versus the alternate hypothesis, which states that at least one of the peas of I's is incorrect, right? It means they don't line up with these proportions. So we should use a chi-squared goodness of fit test if the conditions are met. So they actually told us that random and independent were met, right? So a random sample was used, clearly. And so the second condition is large sample size. He observed 556 peas, so the expected counts are, so smooth was, the expected count for smooth was 556 times 0.75, which is 417. Is that pretty close to, 417 is pretty close to 423, right? And then wrinkled is 556 times 0.25, which is 139. And 139 is really close to 133. I think he nailed it, at least from this experiment that he was doing, right? Okay, so of course they told us the independent condition was met. 556 is going to be less than or equal to 1/10 of n, where n was the number of peas from the pea plants, right? So all the conditions are met. So the test statistic is, so the chi-squared, remember, so in his test it was 423, right? So 423 minus the expected, which was 417, squared over 417 plus, so it was 133 minus the expected, which was 139 over 139, and that gives us 0.345. Okay, and we know the degree of freedom is going to be equal to 2 minus 1, which is 1, right? So let's go ahead and go to our table. So as you can see, for a degree of freedom of 1, the lowest is 1.32, right? So that means we know the p-value is bigger than 0.25. So the p-value is bigger than 0.25, which is of course bigger than alpha, which was 0.05, right? So that means we have to fail to reject H naught. We do not have enough evidence to dispute Mendel's belief. So maybe Mendel was onto something. And of course, since we failed to reject H naught, a follow-up analysis is not necessary or needed.